Hello. This is Ajit B. Singh, your instructor for process control. In today's video, let us see how to mathematically model an interacting level process. The general interacting level process looks like in this interacting level process. A is the area of the tank, H is the height of the liquid column in the tank, F1 and F2 are the outflow from tank 1 and tank 2, Fi is the inflow to tank 1 and finally R is the resistance of valves connected to the tanks. When seeing the overall analysis of this interacting level process, the raise of level in tank 1 affects the dynamic behavior of tank 2 and the raise of level in tank 2 affects the dynamic behavior of tank 1. The flow rate F1 depends on the difference between the heights H1 and H2. When seeing the mass balance equation for tank 1 and tank 2, we can obtain the below shown equation. Fi minus F1 is equal to A1 into d by dt of H1. F1 minus F2 is equal to A2 into d by dt of H2. Where F1 is equal to H1 minus H2 divided by R1. F2 is equal to H2 divided by R2. Substituting the values of F1 and F2, we get the following equations as shown below. Rearranging the substituted equation, we can obtain the equation for Fi and H1 by R1. At steady state, the equations are substituted with the suffix of small s. Therefore the equations become as shown below. Now on subtracting the steady state equation from the dynamic equation, we get the equations as shown below. These subtracting terms can be replaced with dash terms to simplify the equations of Fi and H1 by R1. After dash term substitutions, the equations become as shown below. Now on applying the Laplace transform, the equations turn into as shown below. Now from the equation of Fi, the R1 term is multiplied and simplified in the equation. Similarly, H1 by R1 equation is rearranged, to obtain the equation for H1 of S with respect to H2 of S. Now on taking H1 of S as common in the equation of Fi of S, and substituting for H1 of S, we get Now, we know that τ is the product of area of the tank and resistance of the valve. So on substituting that in the equation of Fi of S, we get On expanding the equation, we get the below displayed equation. On further expansion of the equation, we can cancel out the minus term of H2 of S from the equation. Then on dividing by R1, we can cancel the R1 terms in the equation. So the equation becomes as shown below. The final mathematical model equation of the interacting level process is given by the equation as shown below. The applications of interacting systems is found in various industries like brewing industries, oil and gas industries, chemical industries, pharmaceutical industries, paper and pulp industries, etc. Thank you for watching this video. See you soon on yet another session on process control.